Hey guys, I just wanted to do a quick debrief of the DESMOS activity, Make Them Balance for Monday. So as I was going through, taking a look at this first couple slides, again, this idea is all about like balancing hangers, which is kind of our analogy to an equation here. So if we're making them balance, really that represents the equals. And so in the first couple slides, and you guys had a lot of success here, was just noticing that there's lots of different values for X and Y that can make this hanger balance, right? As I look through, and I can actually anonymize you guys, sorry. You can see all the different possible solutions here. So when you went on the next screen and you were doing some graphing, right, you could see that all of these were solutions to the system. They all are, it's a linear representation. So all of our points follow a line and they all can make that hanger balance. So the new learning is thinking about systems of equations. Let's get this one. Systems of equations where we have more than one equation going on. And we're specifically looking at linear systems, but you can have any type of system with lots of different types of functions. But we're focusing on linear, so we're looking at lines and thinking about, okay, what's the relationship? How do I find solution to a system? And a lot of you articulated it nicely in the last slide, but we're really looking for the intersection point on a graph, or the point in which with the hangers that both of these balance using the same values for X and Y. Again, if you want to think about that in terms of the equation, it's when you can plug in values for X and Y and they're true in both equations. So I wanted to talk a little bit about looking at identifying 2, 7 as a solution to the system. You guys were correct in your thinking here, which was awesome, all 12 of you that participated. And there's a few different ways to check, right? So in your responses, so a lot of you said because you look at the graph, it's not 3, 9 is your solution, not 2, 7, because it's not where they're going to intersect. And also understanding that when you plug them in, it would be for hanger A, but not for B. So I don't think it's a solution to the system of equations, right? So if it works for one, but not for both, it is not a solution to our system. So getting the idea there. Let's look at the next one here. Is this, we've got, which of the following points is a solution to the system? You guys correctly identified 4, 6 as the solution. And as I looked through your responses, there's a variety of thinking about this in terms of the hangers or the graph, right? So a lot of you said, because this is where the lines of the graph meet, where they intersect, so they're equal there. When there's some algebra here, we know that they're plugging in to the equations, and they both have to be true, right? So if they're both true, we know we have a solution to our system. Okay, this was interesting. Looking at a system here, overlay. No. Okay. Let's just look here. So you'll notice that you got both the hangers and a picture of the graph here. You could see what the equations look like on a graph. And a lot of people were trying different things. They could get one to balance out, but then the next one wouldn't. So when we were talking about this, there's no solution here. There is no intercept point, and only a point on the line would work for the system of equations. You can see clearly that the lines of the equation are parallel to each other, meaning that they will never intersect. It means you can't solve both of them, right? So noticing that there's some parallel features going on here. Parallel comes up again, and that is true. And remember that we know we have parallel lines when our slopes, right? Our slope of the function of the equation is the same, right? So these are both 2x and 2x. One response I really liked here was, where did it go? They are the same, except one has an extra 6. So if we think about going back to our hangers, right, that they both have 2 x's on one side and a y on the other, but then there's just this extra 6 here. Well, if we're always adding just an extra 6 to a different equation, like we're never going to get those to balance. So also just thinking about if you canceled all these out, if I crossed out, in fact, I can do that. If I crossed out 2x's here and I did the same there, crossed out a y here and a y here, I've got nothing on this side, but I will always have 6 here. So that means really there's no solution. Okay, so in this one, you'll notice that your lines are, they're on top of each other, right? So they are essentially the same line, but they're represented differently. So let's take a look here. So thinking about this, thinking about, okay, what's going on here? What is the solution to the system? It looks like we could find some solutions here. So what's going on here, right? Why is whatever you plug in, why does it always work, right? What's going on? And thinking about these as, okay, well, what if we did that same idea with the idea of like canceling out what's going on each side and just see what we're left with? So I've got an x here and an x here. So I'm going to cross one out here and one out here. I've got 4 y's, 1, 2, 3, 4 on this side, 1, 2, 3, 4 on this side. So I'm left with an x here, and then I'm left with a 3 and a 3. Well, if these are trying to balance, I'll cross out these here. And I'm left with x equals 2y. So if any value, if I have 2 y's that equal x that I know, I can figure out my answer here. So any situation in which if I double y to get x, that's going to be a solution to my system. And that means that there's infinite solutions that we can come up that would meet that, right? So if y was 1 and x was 2, boom, that works, right? If I switch colors here, if y was 4 and x was 8, another solution to my system. Right? So no matter what, it's going to balance out, which is awesome. Okay, the last one that I wanted to look at was this one. So you guys had a lot of success here, and I love that you were experimenting with your solutions. I was just curious of what might this look like if we wrote this out as a system of equations, and I wanted to try that. So I'm going to use my screen here. So let's say if I know that to make the first balance, I've got 3x plus 9, and I know that has to be equal to this part right here, that second hanger has to be equal to 2x plus 4y. So I know that that's true. Then there's also another equation going on here. Like I know that 2x has to also balance with 4y, so that is equal right there. So really this is how we would represent our system of equations using algebraically rather than using the hangers. So I thought that was cool. And then, yeah, we'll be doing some more practice to see how we can use some substitution to solve that. All right, it looked good, guys. Keep it up, and we will see you later.